Why do Ohm's law calculations not match measured circuit values? Imagine trying to follow a recipe and ending up with a dish that tastes different every time. Sometimes, your calculations don't match what you actually measure in a circuit. That's what we're exploring today. Ohm's law is a simple rule in electrical engineering that links voltage, current, and resistance. It says that the current flowing through a conductor equals the voltage divided by the resistance. But in real life, the numbers often don't line up perfectly. So, why is that? First, measurement errors are a common reason. When you use a multimeter, if the probes aren't placed correctly or if there's noise in the circuit, your readings can be off. For example, if the probes are too far from the component, extra resistance from wires or connections can skew the results. Next, internal resistance within the power supply and the multimeter itself can add to the resistance. Contact resistance from jumper wires or breadboard connections can also cause discrepancies. These tiny resistances might seem insignificant but can matter a lot in sensitive measurements. Line losses are another factor. If you're using long or thin wires, their resistance can cause voltage drops along the wire. This means the voltage you measure at the component isn't exactly what you started with. Also, unit conversion mistakes happen often. If resistance is given in kiloohms and you forget to convert to ohms, your calculations will be wrong. For example, 1 kiloohm equals 1,000 ohms. Forgetting that can lead to big errors in current calculations. Real-world components are not perfect. Devices like motors have nonlinear resistance because of back electromotive force and changing internal resistance at different voltages. This means resistance can vary depending on how the device is operating. In dynamic systems with inductors or motors, resistance and voltage can change over time. Ohm's law applies best to static, steady conditions, so it might not give accurate predictions in these cases. To get better results, use high-quality measurement tools and consider these non-ideal factors. Remember, real circuits are more complex than the simple formulas suggest. Understanding these reasons helps you troubleshoot and design circuits more effectively. It's all about knowing the limits of Ohm's law and working within those boundaries to get accurate measurements.